Afternoon, good morning, good evening, depending on where you're all joining us from today. I know that even for me and our expert panel, we're in very different parts of the world today. So very happy to have you joining us. My name's Eric Linask. I'm from TMC, and I'm really excited to be the host for today's webinar as our experts are going to tackle one of really what's become a critical decision for every enterprise IoT decision maker and leader. Um, you know, uh, you all know how quickly the global IoT market has growing and continues to grow. There are over 20 billion connected devices worldwide right now. And the market growth is going to continue to grow. Expectations are looking at push it moving past the $700 billion mark this year. And it's that kind of massive scale that is also it's creating opportunity. It's also driving a level of complexity, and with more connectivity options than ever before, the sheer number of tech acronyms can really become overwhelming for those having to make these decisions and understanding what the best options are for their connectivity. But it is a decision that has to be taken, and it has to be one that's taken seriously. After all, connectivity, it's not optional. It is the lifeline for IoT. Without it, there is no IoT. So while that's the case, there's also this scenario where right now we're in a huge period of connectivity transition. Operators globally are accelerating. Some are just accelerating the sunset of their older 2G, 3G networks. It's a crucial evolution, but it's a disruptive one that impacts millions and millions and millions of devices and are really forcing migration decisions for enterprises everywhere. And it's not necessarily just about replacing modules. It's about minimizing or alleviating operational risks of devices that are already deployed. The stakes are really high. You have to make the right, clear, informed connectivity decision today that's going to help future-proof your IoT investments into the future, reduce the risk of any stranded assets, vendor lock-in, and the need for expensive, costly field redesigns. So this is the time to plan your secure long-term connectivity strategy. And again, like I said, there are choices. You've got the well-known proven reliability of 4G LTE. You've got the emergence of future-facing options like 5G RedCap and non-terrestrial networks. And of course, there's so much in between those as well. So how do you strategically balance the cost, power, speed, and reach requirements of your particular IoT project? How do you future-proof your deployment while ensuring you've got the reliability that you need today? Well, those are some of the questions that we're here to solve over the next hour or so. And to do that, we have three IoT experts who are here to provide clarity on these and other questions. So I'm really excited to be joined by Martin Whitlock and Jonas Carlson, both from Telenor IoT, and they bring their deep insight and experience into global connectivity strategies that are shaping real-world deployment success in large-scale projects today. And joining them is Lei Shi, who is a principal at Analysys Mason. His expertise lies in market forecasting and tech analysis, and he provides that crucial long-term vision that will help you understand the economic forces that are helping shape your choices and decisions. So again, over the next hour or so, Martin, Jonas, and Lei are going to walk us through the entire cellular connectivity landscape from NB-IoT and LTE-M all the way through the critical role of LTE Cat 1 and Cat 4 to the potential that they see in 5G RedCap and non-terrestrial networks. They'll help map these technologies to your specific use cases and make sure that you leave today's session with a clear understanding and a plan for moving your business forward. So before I hand today's session over to Martin, just a couple of very brief program notes I want to make sure you have. One, we do have some time planned at the end for your questions, so I encourage you, please submit any questions you have as they come to mind. I also know that many of you will be asking, You will be getting, all attendees will be getting the slide deck from today's session following our live event. And you'll also be getting details on how you can access the on-demand version of today's webinar. So you can revisit any key moments, or so you can share that information with any of your colleagues who aren't able to join us live today. So with that, once again, thank you so much for joining us. And it's my pleasure now to turn over today's session to Martin, Jonas, and Lei. Martin, take us away.
Thank you very much, Eric, for that introduction, and also for really setting the bar high here, that we will within this hour manage to explain everything there is about IoT technologies. We will definitely take the challenge and do our best. There may be some things still to discuss afterwards, and we're happy to take that offline as well, of course. Anyways, my name is Martin Whitlock, CTO at Telenor IoT. Happy to be here and having my strong colleagues and partners with me here in terms of Jonas and Lei, which will be the ones providing most of the content of today's session. But before we jump straight into it, just a brief introduction why we're here today and why we have chosen this topic. And that is because we have released a report on the topic of IoT technologies. And maybe Jonas, you can just give a brief introduction of yourself and also what this report is about.
Absolutely. So yes, my name is Jonas Karlsson. I work as a product manager at Telenor IoT. So yes, this report, this is not our first. We have done this many years, and this is the 4th edition, I think. So we are listening all the different technologies, cellular technologies to be used for IoT. And we are trying to help our customers to navigate in this quite complicated landscape. So helping out how you should think, how these different technologies compare to each other. And yeah, this version, compared to others, we have reduced it a bit, only focused on cellular technologies. So it should be easier to digest. And it's based on our experience. So it's not like only fact sheets from different technologies. It's also what we have seen in real world scenarios. So that's kind of important. And also we're trying to answer questions that our customer have asked us during the years. So to add this to this report.
Very good. Thank you, Jonas. And we have been doing this revision together with Analysis Mason and Lei. Since you're with Analysis Mason and be part of the report, please introduce yourself and how you see it.
Thanks, Martin. Yes. So actually, it's my pleasure that I had actually write one of the first iteration of this white paper many years ago. And of course, since then, many things has happened, a lot of involvement in the technology landscape. And it's very happy to be able to collaborate again to write this report. And I think in this case, Telenor IoT bring their operator's perspective or the operational insight. And we as an Mason, a research firm and with consulting experience on different related projects, we bring some independent data points and insights on IoT. For example, the network coverage status and the different module and the chipset volume forecast, so on, so that we can sort of bring a very data-driven story and the insight to you. Yeah.
Excellent. So why not dig straight into it? What do we have at our disposal when it comes to IT technologies? Jonas, what's out there?
Yes. So I will start showing next slide here. So of course, this report have a list of all these technologies and more detailed description on pros and cons and when you should use what. But we cannot go into all these details in 1 hour session. But for example, you have one of the pictures in the report is this one, where we have a summary of how they compare to each other. So I think that could be good to talk around a bit, to just describe. And first, looking at this, we are comparing them, for example, coverage, throughput, latency, energy efficiency, and global availability. And then we list all the different technologies. And as you can see, for example, throughput, we are not listing specification facts here. It's not like, okay, in LTM you have this maximum theoretical values. We are more showing what you could expect in general. So yes, there could be much higher throughput for 5G, for example, but this is what you can expect. And going through the technologies briefly, of course, we have these low power wide area technologies like narrowband IoT and LTM. So these are technologies that are really good for scenarios where you don't need to send so much data, and maybe not so often. They have quite cheap devices. You can have a lot of them, and they're really good on coverage because they have enhanced coverage functionality. Also, when it comes to energy efficiency, they have special features for pausing and save battery. So that's great. But as mentioned, they don't have such a high throughput, so it do not matches that. Also, you need to know that narrowband IoT is quite a long latency. So we will look into a little bit more detail about where you can find it, but both of these technologies will be quite spread out around the globe, but not fully global yet. Then, of course, we have 4G. Here it's specified as LTE. LTE is 4G is the same thing. 4G has different flavors, so it comes in different categories, as you probably know. So it goes from the lowest one, category 1, up to Cat 4 and higher for higher throughput. So Cat 1 and Cat 1 bis, the Cat 1 bis is a special version of Cat 1. It's more or less exactly the same. It's only on the device side that it's only have one antenna. And with Cat 1 and Cat 1 bis, you can have really small and cheap devices. So that's really good. It has much higher throughput compared to low power wide area technologies, but still quite limited. If you need more throughput, you need to have Cat 4 or higher. So that's good for high data usage. The really great thing with 4G is that it's nearly universal. You can find it more or less all around the globe. So that's really beneficial. Then, of course, we have 5G. 5G has also different flavors. You probably heard about 5G non-standalone, 5G standalone. 5G non-standalone, that's the solution where the operators have enabled 5G new radio in the network. So you can have this high throughput, but they have not yet activated the 5G core. So you still need 4G to be enabled to use this. You connect your device via 4G, and then you can level up to 5G radio to have this high throughput. 5G standalone, 5G SA, that's when the operator also have deployed the core, the 5G core, and it's when you have 5G SA that you have the possibility to have the 5G features like slicing, edge computing, ultra low latency, etc. We will look a little bit into where you can find these technologies later in this report, but also want to mention RedCap, 5G RedCap. So 5G RedCap is a quite new technology. So it's also building on new radio, but it's RedCap stands for reduced capability. So here we have lower specifications. You don't need to have as many antennas, MIMO, etc. in your device. And that will make it possible to do smaller and cheaper devices. It will not have the high throughput as you have with standard new radio, but it will match a lot of IoT use cases. So you can compare it a bit like from Cat 1 to Cat 4 in LTE, that type of use cases and throughputs. eRedCap compared to RedCap. eRedCap is called enhanced RedCap, but it's actually an even more reduced version. So it's even closer to LTM and narrowband IoT. So you can do even smaller devices, cheaper devices with less capacity. And the last one is non-terrestrial networks, satellite communication. I will not go into so much into this now because we will come back to this later. But this is how to enable cellular connectivity, but from space instead. Yes, I think I hand over to Lei.
Yeah, Lei. I mean, we also look at this chart now, and as mentioned by Jonas, we have done a few revisions of this report over the years, and you were part of one of the original ones. What would you say has changed the most in the recent updates? What's new?
I mean, we can look at the volume forecast in a bit, but I think just a quick reflection back when we started with this white paper series, there are a lot of focus on the low power wide area back then, and the Cat1B and the Cat1bis was not on the radar even in the initial version of the table. But as you can see here in this chart, the yellow bar is showing the volume of IoT connections using Cat1 and Cat1bis, which, as you see, is basically taking over almost 1/3 or half of the total volume as we going towards 2030. I think one of the reasons, as I think we'll discuss a little bit more later on as well, is basically because it's a standard 4G technology. It's available as long as your 4G network. So, and we know 4G is everywhere today. So that's why Cat1 is a very, very easy choice to go for. And also the volume is going up. That means the modem price is going down. So it's a healthy cycle to be in as this technology starts taking off. And if we look at the low power wide area options, NB-IoT and LTM, yes, I think they're still growing. I should note that this data shows the numbers outside China. So if we include China, then NB-IoT has a much higher volume, of course. But even outside China, those two technologies are still growing, but they are growing at a much slower pace. I think if we're reflecting back, this is probably less than we initially anticipated a few years back in terms of their take-up. I think there are several reasons that can explain it. One is that there's a bit of fragmentation of the global availability. You could say they are serving more or less the same area, but one is available in some market, but another is not available in the same market. And therefore, I think for a lot of international enterprises, to have a global availability to be able to roam, to have roaming support is very important. I think that's another reason why we see Cat1 has become a favorite. And also, on the very top of those bars, the dark blue is showing the 5G, which includes 5G RedCap. We didn't spread out because if you spread out 5G RedCap, it will look even smaller at this point. But of course, in the coming year, it will start to get a bit more volume. But as of today, it's a very nascent technology, I would say, and we will also explain a little bit later why it's that. And obviously, the gray bar, as you can see, the 2G, 3G devices are ramping down as the global sunset is setting in. And also interesting to note that the standard of 4G, Cat4 and Cat4 Plus has basically reached the peak now, and they start to gradually decline in the coming years. And I think the one explanation could be that a lot of use cases that used to use this standard Cat4 can be actually addressed already by either Cat1 or can be addressed by 5G if you have a bit higher requirement. So those use cases start to diverge into those other two options. Yeah, but I think these are quite interesting trends to see over the time. Yeah.
Absolutely, I agree. And I think you had as one of the categories, Jonas, in the comparison chart, you had the coverage. And I think there's probably two parts of that parameter. One is the coverage from the base station. How long does the radio signal reach from each base station? But also coverage, of course, from a perspective, where are the technologies deployed? And those are not necessarily the same. And I think with that, we have the 2Gs, the 3Gs, the 4Gs, and the 5Gs, all mentions. What's the status of the rollout and the shutdowns? And I think one comment to your slide there, Lei, as well, with the number of connections. I think if you would have a few years backwards in that, I think start with 2020. One interesting fact, I think, is that even 2G were peaking like last year. So it's a very old technology that in terms of number of connections peaked last year. But Jonas, couldn't you guide us through a little bit? Where are we on 2G, 3G? You have the slide up here. It's been sunset.
Yeah, exactly. So I think let's start with the legacy ones, the oldest ones. that we are now starting to phase out. So let's start with the sunset. So as you all know, and as we have talked about already, 2G and 3G sunset is a fact. So it's going on, and you need to keep track on this. And the reason, of course, it's old technologies, not as efficient, so operators would like to swap that to newer ones that are more efficient, and freeing the frequencies, etc., that the old ones are using. Looking at this picture, just trying to describe what we are looking at right now. You have this yellow orangish color that shows areas, countries that already done the full sunset. So they have already swapped, turned off 2G and 3G totally. And then you have the dark blue. That's where you have turned off 3G, because that's quite common that you start with 3G to turn that off and still keep 2G. So they have that in dark blue. The really dark, almost black here, I think, that's not so common that you turn off 2G but still have 3G, but there are some areas that do that. And the rest, the blue, light blue ones, are where you can still have at least one operator in that country that still supports 2G and 3G. But it's really important to monitoring this and to look into the countries and areas, regions where you have deployment, where we have devices. You need to keep track on when are the plans for sunset, because it will happen sooner or later everywhere. So and actually 2025, the end of this year, it's a number of operators that have the target to turn off things at the end of this year. And before that, it's important that you have tried out your device. How will that react? Because even that you have 4G, for example, maybe you have a device with LTE or LTM with 2G fallback. It's really good to test that. And you can do that, for example, in test labs. IoT, for example, have a test lab. But it's good because we have noticed that we have customers that have challenges, that when this happens, they go berserk. So that's important.
Yeah, I think I could also just add on that. We also see our clients when they thought they had a foolproof plan when to handle the 2G, 3G sunset because they have a fallback technology, but when it actually happened, because the coverage are not exactly the same, even if you are fallbacking from, let's say, 2G to 3G, then the device you had in the basement that used to work now suddenly stops connecting, and you don't know why. So I think one lesson is that you should always be ready to have a team to be prepared to go out to the field to be ready to manually restart the device, or sometimes the firmware update didn't work or didn't push it through over there. Then you need to make some manual changes just to be ready when the 2G, 3G sunset happens. Even if you have a device ready, the lab tested, there might still be something that need to fix. And I think another thing I would comment on is, as Jonas, you mentioned, that each country is a little bit different, and even within a country, you have to look at operator by operator. In most markets, the sunset is not a single sort of one point cut over, but rather a multi-year sequence, and operator can have different schedules. For example, if we look at Germany, the latest we had is that Vodafone Germany has planned to sunset 2G by end of 2030. Deutsche Telekom says mid 2028, and the O2 Germany hasn't even stated any date. And some of these informations are not public available in many countries as well. And you only get to know that when you start to send out customer notice, or we stop onboarding new device on this legacy technology and so on. So it's not easy. It's not always easy information to get hold of. That I think that's what I'm saying. And sometimes I think in past engagement, we also get help with IoT to get actually the most comprehensive information about the different sunset status around the world. And I think another aspect to consider is that when sunset happens, this typically start with the refarming on some of the spectrum bands. So they start to free up some of the bands used in the legacy technology for capacity to be used for, let's say, 4G or 5G, and to keep only a few megahertz of lower bands just to make sure they have a last slice of coverage available. And the timelines you got from how long the sunset will take or how long they will keep the technology usually are referring to the last piece of coverage that are kept alive. So that means you probably would experience there are reduced capacity or availability of the network, even though the sunset is set at a later stage. Yeah, but if you are using some sort of low capacity, low data rate use cases for IoT, then this may not be a real issue. But if you're relying on this connectivity for high throughput traffic, then it might be something you want to be prepared early on rather than waiting for the last date of the sunset. Yeah.
That's so true. And as you stated, Lei, it's not easy to keep track on this, these sunsets. And we're doing everything we can in our power, of course, to communicate with all our partners around the world to keep this up to date. And we send that information out regularly to all our customers. And that's at least one way to try to keep on track. But looking 2G, 3G, if we categorize those as legacy technologies, even if they are still to a high degree used, looking forward then, Jonas, what about current technologies or technologies to come?
Exactly. So I think let's start with low power wide area technology. So the narrowband IoT and LTM. And as we talked about, you can find them quite widely, but not fully global. So in this map, for example, you will find that the darkest color here, then we'll have both options, and that's quite common. That operators, either one or the other operator supporting narrowband IoT and LTM or both at the same time. It's not as common to only have LTM, but you have a few. That's the orange yellow color, and then you have dark blue. That's especially in APAC, you will find countries that are focusing on narrowband IoT. So that's a fact. But then also you have countries that do not support this, as you see a lot in Africa, for example. So there you can see the rest, every color here that is not gray will have 4G. So once again, we come back to that 4G is extremely well spread, more or less fully global. You have a few countries that do not have 4G. But so, and when we're talking about 4G, we're talking from Cat 1 and upwards. So from the quite small and cheap devices like Cat 1, Cat 1 Vis up to high speed 4G routers, for example, could be used here.
Safe bet then. How safe is it, Lei?
Yeah, maybe I don't want to be party pooper here, but I think there are maybe some people. I saw the latest news that this in US, T-Mobile has a leaked plan for potential sunset, 4G sunset, targeted until 2035, I think. But I think sorry,
or for LTE.
Yes, for LTE, exactly. Yeah. I think that the leaked plan is that they will start to refarm most of the LTE spectrum to 5G over the coming 2 years, but at the same time keep 5 megahertz available for the legacy 4G device until 2035. This is getting some coverage in the telecom space at least, but I think I would not overreact, because we should also note that T-Mobile was is the last major US operator that sunset 2G, which has happened earlier this year, where the other two operators have sunsetted much earlier. So I wouldn't say necessarily see that they were in a rush to sunset 4G. And also I think historically these sunset run by the operator take usually longer than they initially planned anyway. So I would say we would expect a progressively LTE sort of down prioritize in the network, but it's not going to be a stop in the near future.
Oh, I think you're definitely right there. And just look at 2G. I've had it for decades now. So yeah, 4G is here to stay for a long time, I'm sure. 5G then, and maybe also RedCap. There's been a lot of buzz about RedCap recently, and you mentioned it in your introduction as well, Jonas. But what's the current status, and how should we look upon RedCap today?
Yeah, I think I will start with 5G in general. So yes, a lot of operators have invested in 5G. More than 600 operators have announced that they are focusing on 5G. So that's really common, and especially then a 5G NSA, non-standalone. So I think looking at this map, I think we can start from the bottom here. So the gray areas are countries, areas that do not have any 5G at all. So everything with color have some kind of 5G, and normally that is at least 5G not standalone. So the yellow ones, they are the ones that have 5G, but they have not implemented the standalone yet. So they have 5G non-standalone. And then the light blue, then you have some kind of 5G standalone services ready. So you can see it's quite a lot of countries that have that already as well. And the last one, and we're coming back to that, the RedCap, it is a very, very new technology. Specification-wise, it came in 2022, and the next was like last year, the eRedCap was released there. So it's very new. It's not so many devices out there yet, etc., etc. So therefore, it's only a few operators that have launched it. It's a number of operators saying that they're doing trials. It will come, and it's, as we talked about, it's a great technology that will match IoT scenarios really, really well, and still they have the potential to have really cheap and small devices. But right now, they are not spread. They are not global available.
Yeah.
So yeah, it's in its infancy yet.
Yeah, and I think looking at the light blue colors, they might on this map it might actually look better than in reality, because I think what we have how we color the different countries, that as long as you have a country announce that the operator announced that they deployed 5G standalone, we color it light blue. But in reality, it's not necessarily rolled out nationwide. And in many countries, especially looking at Europe, yes, there are many countries that they said they have 5G standalone, but when you go to the actual network, they don't have it widely spread. They might have it in a test area or in 1 or 2 cities, but it's not countrywide coverage for sure. And with that said, if you don't have 5G standalone, as Jonas mentioned, then you can't really deploy 5G RedCap. So I think that's also a reason why we only have basically 2 largest countries here, US and China, that are leading the 5G RedCap, because they are the countries that actually have done a nationwide standalone 5G standalone rollout. In most of the other markets, the 5G standalone are still in a more like test and trial phases, which is to the frustration of many sort of network vendors, and they try to change this. But unfortunately, I think in Europe, for example, the operators are very much capex constrained, and they are struggling to see why they need to invest in 5G standalone when they don't see a clear revenue return. So that's why they are stuck in this trial phase. They started implementing it, but they don't see immediate benefits, so it didn't really roll out in wide scope. We hope this will change, and we are, of course, seeing a new development in technology that might bring other benefits for having 5G standalone. And if that happens, then as an add-on to that, 5G RedCap will become like more available sooner, hopefully.
Yeah, I think it's exactly like that. And if you've been around in telco for a number of years and generations and rollouts, you know that this is not unusual, that it's spreading out across the world and the different deployments in different phases in different parts of the world. So it's just how it is. And I think the drawback may be from those who want to deploy IT solutions and have one technology to cover the whole of the world. It becomes a little fragmented with this timing differences. But and maybe 4G is the way to go now. Where we should conclude it on the other slides. But talking about new technologies and maybe global technologies, going to space, what's happening here? And non-terrestrial networks were mentioned. What's the status?
Yeah.
You want to start?
I promise that we will talk a little bit more about satellites in the beginning there. So here it comes. So yes, it's a lot of fuss and news about satellite in the cellular area nowadays. Every week you see something new, and we have had satellite communication for a long time, absolutely, and it's really great. The possibility to have connection, even that you are not in the city, you are in a rural area. So that's really great. But what is the difference? Why is it such a lot of buzz about this right now? And there are few components that makes this. And for example, one thing is that the legacy satellite communication, they are dedicated hardware that is only used for satellite communication. So you needed to have a satellite modem that did this connectivity. Now the new thing is we talk about direct to device or direct to cell. You can have cellular devices that can also use standard cellular technology in the same device and same modem that also connect to the satellites. So you don't need two different devices or modems to handle this, and that's really beneficial. So that's one big part. And another big driver why there are so many new players jumping on this train, it's the LEO satellites and the cost to send up satellites. So back in the days, it was more or less always geostationary satellites. They are huge ones. They are long away from Earth. Really expensive to build and send out. Now with LEO and new ways to send it up in a much more cost-efficient way, it's reachable for many more enterprises and vendors to start this. So that's two key factors why this has really taken off. And yeah, it's every day something new. So I would say it's still early. Once again, it's like RedCap. It's still early. It's in its infancy, and companies, when you see their websites, it looks like it's up and running and fully fledged already. But normally, they only have a few satellites up until now. But this is really promising. This could be a big game changer to have connectivity not only where you have terrestrial coverage, but also as a backup when you are out of terrestrial coverage.
And I would like to add that what we say here as a standard cellular hardware doesn't necessarily mean it will be backward compatible. So even with all the sort of direct to cell headlines, you actually still need a new, your existing Cat1 or LTE devices will not just see satellite naturally today. You still need new device to be able to do that. But of course, this means that your new device will have you can leverage the scale and ecosystem of cellular devices, which is much larger than the niche traditional satellite devices we had before. And I think I echo what Jonas was saying about the stage. I mean, at Mason, we have a dedicated research program on satellite, and we'll keep monitoring this space very closely every day. And it has been we got lots of queries in recent years because the buzz around it. But we often have to calm our client down a little bit. It's still early days, as you say. There are lots of launches, but if you look at any particular satellite service providers, you typically don't have that many satellites in orbit yet. At least not able to provide the global or wide area coverage that you'd hope for. And there are still some trials or have the limited corridors. But I think even though that being said, I think today you can still start to consider satellite as a coverage, complementary coverage, as where you don't have a terrestrial coverage existing. That could be the maritime legs, cross-border corridors, and so on. So if you're planning to expand the use of satellite in the future, then you can already start to think about what antenna powers and your device would require, and maybe also take into consideration the fact that it will come with a higher latency and probably higher cost at the beginning as well.
Thank you. Yeah, but it's cool. It's going into space.
Yes,
That's
it's cool.
that's
Yes.
always so yeah. All right, Jonas and Lei. Now we have introduced a lot of different technologies, and I think Eric put the bar that we would be able to help guide in the right direction. Maybe we just confuse the audience even more by sending out the smorgasbord of different technologies. But is there any way, Jonas, to try to narrow this down to a recommendation of sorts? And how do you need to think about that?
Yeah, I think we will come to the recommendation really soon. I just want to mention that in this report we also have a chapter regarding finding the right use case for right technology, and we will not talk so much about this here now. You can read it in this white paper. I just want to mention that it's very important, and maybe that's actually the conclusion, that focus on the use case and not the technology. That's one part. But yeah, jumping on to the summary here. So yeah, I totally agree. So, but one part of this is it's so important to focus on the use case and really walk through what you need when it comes to latency, throughput, etc. Which areas are you going to deploy? Or if you're focusing on LTM, for example, will you find it in that area where you want to deploy, etc. So start with the use case before you select the technology. That's one recommendation.
Definitely. I think that's actually something that I often also try to recommend customers. And I say that even if I'm the CTO and I should be talking about technology all the time, I think it's very hard to talk about the technologies without understanding the use case. So you need to start there, because it's easier to turn it around, probably say that if you have a use case and you need a technology, we cannot help you find the right technology for that use case. But vice versa is very difficult to do. Then you start off in the wrong end. But provided that you know what kind of use case you want to fulfill, I think one of the takeaways here is to look at what the network technologies are actually available today. And we gone through everything from 2G to 5G to satellites today in this session. And I think we've said it already that LTE, 4G, that would be the technology, at least in my mind, that has reached global scale already. That is most available of all these technologies from a global perspective, and not prone to be sunset, at least in the short space, even if some operators apparently started to leak information that they are thinking about it. But that's very, very early, I would say. So LTE is probably a safe bet. I think that also, while it's super exciting with the new technologies, and to be frank, there are definitely use cases out there that would benefit a lot from some of the latest technologies, like satellite. If you're expecting to connect overseas, for instance, or oil rigs, or in super remote areas, for sure, start to look at the satellite options already now and do business development based on that. Or it could be so that you really need the advanced and low latency capabilities of a 5G standalone network, even if you should know then that as of today, you probably will mostly find those in certain markets, urban areas, where it has made sense to put the capex in. If that's sufficient to start doing your business development already now, by all means do so. You should, and then you're probably well prepared for the future, as well as those technologies are even more available globally. So, but you need to consider this, at least what is actually a hype right now, what is expectations for the coming years to be rolled out. We talked about the sunsets, and I think turning out to those who have a large fleet maybe already of existing IoT devices out there, it's very high time for many markets to start to look at this. Some markets are already completely out of 2G, 3G, but others are coming as well. So it's going with your verification that devices will actually cope with the sunset, and they all look back to 4G if you have those capabilities and so on. Then, yeah, when it comes to the future, I think that's also something that you can consider, that even if LTE is the technology that's most widely spread today and makes a lot of sense to include in your new launches now, there could be opportunities to include future technologies as well, even if you don't rely on the fact that 5G or RedCap or whatever it is massively available right now. It could open up for new use cases in the future by firmware updating your devices, and then you're ready. So I think that's at least an interesting possibility to consider. So build for future flexibility. And then the general recommendation when it comes to launching IoT doesn't necessarily have to do with the choice of technology, but I think it's always good to start small and build for scale. It's easier said than done, but at least it should be considered. I think we have seen a lot of successful IoT deployments that has had that mindset from start, that, yeah, there's a value in connectivity in your devices, and this is how we intend to go by with it. So those are, I guess, in summary, some of the takeaways, unless I forgot something and Jonas and Lei want to complement. Otherwise, I think if we invite Eric back to the stage and see if there are any questions that have popped up along the presentation here.
Yeah, and I think you summarized it very well.
Absolutely. Thank you. With some amazing information and insight there from from your report, and obviously Lei, your insights from your research and analysis as well. Hopefully that was all very not only interesting but useful for our audience. But yeah, let's see what we have for some questions here. Maybe the best place to start here is, you've talked about all these different alternatives or options for connectivity going forward. Enterprises have to make this decision. What's the biggest mistake that enterprises tend to make as they're poring over which way, as they're making this decision?
All right, and I can start, and then please, Jonas and Lei, fill in on yours end as well. I think when it comes specifically to choosing technologies, I think I touched upon it a little bit in the summary there as well, that we've seen enterprises getting excited about the latest technologies, just to realize that the coverage availability in the markets they wanted to launch that the connected devices didn't really match expectations there. And I think that happened when the low power wide area technologies came out. It took very long time for narrowband IoT and LTE-M to be turned on and launched in a lot of markets. Now we see that we have traction globally for those technologies as well, but it took time, and we need to respect that. And also the fact that from a marketing perspective, I think there are different players in this industry. There are suppliers of modules, and there are suppliers of networks, and there are operators, and the interests in talking about the new technologies could differ depending on who you're listening to. And it's easy for a network provider, for instance, that want to sell the latest base stations and the latent core network to only talk about the future technologies, because that's how they build up a demand, so to say, in the industry. But it might take time for the operators to invest in it. It might take time for enterprises to get those technologies integrated into the devices, and without scale, the investments, the willingness to invest is not really there. So I think that's a pitfall, to fall for the hype. and if you do, you might get delays. That's one thing at least.
I think I can just comment on that. It's not based on project experience that we had 5-6 years ago, to say that I also empathize with the enterprises in the sense that they wanted to know what's coming and what is the right choice now, even though we're looking at 10 years ahead. Because for automotive manufacturer, their products are going to be out in the market for 10, 15 years, right? They need to make sure whatever they put in the car is the right module that's going to be still working in the 10 and 15 years time. And to procure that module to manufacture a car, there might be another 2 years of lead time. So it is they need a very long time horizon to make that decision. And of course, our recommendation back then is more that yes, you need to build in some flexibility to cater for the future evolution. But I think maybe it's worthwhile to put more effort to understand what you can deliver with the existing technology in the next 5 to 10 years, rather than spend too much effort trying to be future-proof, because you can never really be future-proof. It's more about, I think, what your use cases can be realized using more available technology right now, so that you don't need to spend another 1 year of a strategy decision to study to find out the best future-proof option.
No, I can just agree. And to have the flexibility to not I think something that we have seen quite a lot is focusing, for example, on narrowband IoT, because that's the cheapest devices. It's really attractive to be able to use that one, but then it turns out that you have a challenge, for example, with software updates. If you have any challenges, you need to do an upgrade or something like that. And also it could be like your use case can change over time. So if you have like an energy meter back in the days, it was perfect for narrowband IoT. It only sends like once a day. It sends the data, how much energy that was consumed. And all of a sudden, your country have new regulations and demand that you need to send it every 5 minutes or constantly, or more data. Then it's a challenge with, for example, narrowband IoT. So you need to be to have a little bit room to grow, even that maybe you don't need it here and now. But that's, of course, it's a challenge, and it's a price discussion and things like that as well. But things that we have seen happening.
I love the chart, the slide at the beginning that showed the different characteristics of each of the connectivity options. Coverage, throughput, latency, energy efficiency, and so on. The one thing that table did not include, and I'm wondering to what extent is or should cost be a factor, and how does cost play into each of those different alternatives?
It's a good question. I think there are different ways to look at it. I think first of all, you have cost in the sense of deploying your technology in your product. So there, of course, a more advanced technology or high bandwidth technology usually have modules and antennas and radio design patterns and stuff like that drives cost at the end of the day, right? I think that what Jonas said as well, you get attracted by narrowband IoT maybe because those modules have had the lowest bill of materials basically to embed, historically at least. I think what has to be balanced then against that is, of course, availability of the technology. As like we mentioned, LTE is quite widely spread. So does it mean that you can't launch in all markets with just the cheapest module? Then you need to consider, is it worthwhile to having two variants of your connected device, one that is intended for a market where narrowband IoT or LTM is available, and another one for markets where it's not? Or is it better to embed a little bit more expensive module from start that that is more global. I think that's one thing. I think then once you have the technology in there, when it comes to the actual connectivity, I think it doesn't matter that much usually what type of technology that you're using. It's the amount of data that you're transmitting. So then it's more back to the use case, I would say. Anything to add there, Jonas Lay?
No, but I think what you said about the connectivity cost, I think that's a really good point. It's not about if you're in 5 to 14, and it's about how much data you're sending over, so that you can dimension that that aspect, the cost yourself already.
Yeah, and the cost of being forced to upgrade your device earlier than you wanted to do. If you are looking for a lifespan for 10 years, and it turns out that after 5 years you're forced to do that because you save some money in the beginning, then it can be really costly to try to reach out to all the devices and upgrade them. So but it's hard to know beforehand. So it's always a challenge. It's always a give and take.
Fair response. It makes a lot of sense in the world. Thank you. Can we kind of take a look at a scenario where we're monitoring global shipments at scale? How would you reduce the choice of protocols in a situation like that, for a deployment scenario like that?
Yeah. Jonas, you go ahead. You were taking breath there.
So I understand the question. How to reduce what technologies you need to have, or what?
Right. So there's a fairly long list of connectivity options. How would you pare down that list?
I think that we have talked about a few times here. Looking at which ones are globally available, fully out, that helps out. So if for example, you have a match with Cat1, Cat1 bis, for example, then you can have one and the same technology being used for very broadly, globally. LTM, for example, yes, if you are in Europe, for example, that will work perfectly fine in US. But if you are in Asia, that could be a challenge. So then you need to have some backup. Most of the time, maybe they go for LTM and narrowband IoT device. Quite often, there are multiple technologies in the chipset. So that's, I think that's an important aspect to that, even though it could be you are tempted to have like an LTM only device. Normally it's beneficial to have multiple technologies. It will cost a little bit more, etc., but in the long run it's probably easier to find a match that we can have one device that could be used in more places. I don't know if that was also on the question or not, but
no, I think that's helpful. Lade, anything you want to add? I think we have time for one more. It's an interesting one. So a lot of conversation about edge computing. It's sort of tangentially related. A lot of conversation about edge compute lately. How does edge compute devices solutions play into connectivity, and is that a good option for companies in terms of future-proofing their investments?
Well, I think that goes down to the use case, to be frank. What you need to do is, I mean, I think edge computing could be a waste of money to implement if you don't use it as well, because it will cost, of course, to have the capability there. While in other cases, and we have customers that, for instance, do huge amount of analytics of car sensors for support systems, maybe not full autonomy of the autonomous driving, but still there are cameras and radars and what have you, and that needs to be digested quickly. Sending that back to a cloud and then give instructions back to the car would be very costly and take time. Edge computing, I think, is a great way of doing that efficiently, and then only send metadata and learning protocols back to the cloud and teach the models in that way. So really depends on how you what kind of use case you have, I think. Once again, that's where you need to start.
So Martin, actually, you are referring to have the computing on the device when you say.
Oh yeah, in this case, I think true. There are edge computing that could be close to the device as well, in the base station, after the base station, or something like that. Typically comes with 5G SA.
Yeah, exactly. Yeah.
Yeah, and that was my fault. So if we elaborate a little bit about that, normally if you have that type of edge computing, then we are more talking about how to enable low latency. That you need to have your data service quite close by to have this really ultra low latency. Quite often when we talk to our customers, it turns out it's not needed to be this ultra low latency. Most of the time we end up it's low enough latency, so sometimes you don't need the 5G SA edge computing to be able to handle that use case you're looking for. So that's also something to consider. What are the demands for your use case? Because we have had that customers are requiring this, and then when we start digging into actually what is going to be used for and start measuring what is the limit, then it turns out that now it's not like 5 milliseconds that are needed. If you are 50 or under, then it's totally fine. So quite often it turns out like that. So, but the edge computing could be both, as Martin talked about, on the device and how to, but also on via 5G SA and achieving ultra low latency. I think you're muted.
Excellent. Looks like some future conversation that we can have around edge compute as well. I think that really does take us to the end of the time that we have for our audience. If you haven't already, just do want to point out the QR code on your screens where you can download the connectivity technologies for IoT guide. By all means, do that. Again, be on the lookout for additional information, contact information for the Telenor IoT team if you have additional questions. Also details on how you can access the on-demand version of today's webinar, and again, the slides from today's presentation as well. I do want to take a moment to thank Martin Whitlock, Jonas Carlson from Telenor IoT for sharing their expertise, and Lei Shi for sharing your analysis from your background and research, and also, of course, the team behind the scenes at Telenor IoT for sponsoring and producing this whole webinar. Again, I hope this was a useful activity for everybody. Thank you to our experts for sharing your insights, and hopefully we'll see you all again here very soon.
Thank you, Eric.
Thank you, Eric. Thank you all.
Thank you.
Thanks, everybody. Have a great day.
The same to you.